Welcome everyone. My name is Marcel Costantini and I will talk to you today about a project my team and I worked on at the European Space Agency's Astronaut Centre, dealing with improving the lunar analogue for testing space rovers. In order to prepare for future exploration missions to the Moon and beyond, ESA decided to establish the future Lunar Surface Analog Testbed, LUNA, at EAC in Cologne, which aims at representing a precursor Earth model for the future Moon village, and will consist of the following elements. The Lunar Regolith Testbed, plus its labs and other functional areas, that's about 1,100 square meters. We have the Flex Hub Moon base module, we have the Flex Hub energy containers, and additional integration with the neighboring DLR Hub Medical Research Centre for space. So who may use the facility? Well, Lunar Analog is an open incubation hub, just like the Moon Village. It's an open concept. So ESA and DLR wishes to generate an open hub for everyone and conduct core research and development in priority areas aligned with identified technological gaps. So what we're doing here, we're trying to confirm and detail the interest of planetary exploration robotics in Luna. And a few studies already exist about lunar analogues in Europe, but with Artemis and the latest technological developments, nothing up to date was available to confirm and detail the interest of, well, rover developers in an indoor lunar analog in Europe. We would like experimental moon rovers and their systems to be tested in a controlled environment there, and even teleoperated from another location. Furthermore, we want that at the end of a test campaign, the resulting data would be able to be kept by the visiting organization. So for doing that, we would like to ask the experts and consequently influence the design of Luna. The methodology is rather simple. We listed pretty exhaustively every organization that was working in Europe on space rovers and sent them questionnaires, and we've got 28 respondents out of that, which is a fair sample of the overall population, allowing to analyze and good recommendation to allow good testing of planetary robots in Luna. However, the findings that we have, and one of our conclusions from that is we need a deeper study into the sun simulator, because the responses were overwhelmingly stressing the need for it. So the intersection of computer vision systems with these 28 responding organizations only resulted in 6 interviews, which are still covering most of the organizations that are both working on space rovers and computer visions. For that reason, the analysis that we have of these interviews still yields valid recommendation for the sun simulator we want to build in Luna. Here's the data that we've got. For robotics, people are overwhelmingly wishing to have a good regolith landscape and good realistic lighting condition, either here as a dependency or as one of the most useful features. Close by afterwards, you got a position tracking system. Now, they would love to use all of that during different duration. You can see here, there's about a third that needs more than a week, a third that needs less than a week, and another third that needs less than a day. So it varies a lot. People, half of them would need to have a team remotely testing, others wouldn't. Everyone recognized the need for testing, and in fact, most people already did testing. 2/3 of the people would bring then their own rovers rather than the other third wishing to interface with a rover that they don't own just by slapping their system on a pre-made rover. But an interesting bit was, if you look at the data they'd like to take home after a test, 70%, 77% is about software log files, and 82% is about video recordings. Now that is actually a lunar influence. For tackling this, we need to ensure that there's no regulatory problems, no technical issue either in providing what could be weeks of video footage. The regolith landscape is favored by people that wishes to test locomotion and propulsion systems. So we need to have repeatable and precise landscape shaping, something we intend to do. And we'll have another talk about the sun simulation, but we really need to build the highest quality sun simulation we can inside Luna. Last, we really need a position tracking that serves as a ground truth, accurate enough so that we can test inside Luna experimental rover onboard localization systems. Half of the respondents would love to use a rover they don't own, so we may want to build that rover they don't own. Half the people would love to test their systems remotely. We need to prepare for that as well. Last bit, we need to ensure flexible booking for all of these tests that are either a couple hours or more than a week. The sun simulation. Here's all the data. The sample size is much smaller, as previously noted, and the questions are very wide encompassing, so bear with me here. The spectral zones that are of use, it's mostly the visible light, like there's a few of the infrared, but it's not predominant. The polarization is mostly not used unless you're looking into atmospheric rovers on Earth or on Mars, which is not the case on the Moon. And mostly people don't care about the absolute radiated power of the sun. They don't need the 1300 watts per square meter. But they'd love, almost all of them, to really be able to tilt the sun relative to the ground. It's very important, or at least it's a plus that they would use. People, however, are much more diverse in their answers. Only a third of the respondents were able to pinpoint how far do they look on the ground. And another third actually say that they look up to the horizon. So the simulation area for the sun simulator really needs to be as big as possible. Geometrical accuracy is actually important, like either very important or somewhat important. And that accuracy needs to be as high as possible. People would wish to be completely fooled into believing they're on the moon, at least as far as their AGB sensor is concerned. So overall, what we need a movable sun. We need to be able to have as big as possible late simulation area, and if possible, even having an optical illusion up until the horizon. The color accuracy needs to be as good as possible in order to fool the sensors that it is on the moon and not on the simulator. We need to reproduce visible light, but we do not care about invisible sun radiations, neither the polarization properties of the sunlight, and we don't need to reproduce the entire 1-to-1 scale luminous flux, which is a relief. So in conclusion, we did understand better the interest of planetary rover developers in facilities like Luna, and we've influenced the design of Luna thanks to this new understanding into best having hand-in-hand humans and robots doing planetary space exploration. I'd love to leave you with a last bit that came again and again during the study. Numerical simulation done by randomized respondents are easily repeatable, but it's hard to prove that they're representative, especially if you're thinking about interaction models between soil and a wheel. And on the other side, a field simulation is much easier to prove that it's representative, but because of weather or ephemeris, it's hard to make these tests repeatable. And that's where facilities like Luna allows to make simulation that are representative and repeatable, something of very high value that was praised multiple times. As again, thanks for your time. I am Marcel Costantini. Do contact me if you have any question. Bye.